so we've got a little bit bigger of a table on this problem, and if we look at it, they give us in the same table, they give us information about two different functions, f and g, and their derivatives. And then notice this is something we haven't run into yet in these problems. They give us these intervals. They give us specific values, but then they tell us between those two values, we've got this kind of sign going on. But so essentially what we have here is we have a sign test chart. You know, normally we would make our line like this if we're talking about f prime, -1 and +1 are where our derivative equals 0, and then they have chosen some test value like -1.5, and the sign has been negative on that interval. And then between -1 and +1, say 0, they plugged in 0, and it was negative on that interval. And then from 1 to 3, so let's say we plugged in 2, it was positive on that interval. So that's essentially what we're looking at. We're looking at a sign chart just in table form. So they tell us that the two functions are twice differentiable. So we're looking at the first derivative, but they say that we can also find the second derivative for all real numbers. So that means that there's nowhere where it's not differentiable, where the derivative doesn't exist. Part A, find the x-coordinate of each relative minimum of f on the interval from -2 to +3. So when we see any kind of extrema, but this says minimum, we should be thinking where the derivative equals 0. So I would circle those on my table. I would tell myself, okay, so I'm talking about f, where I have extrema, that's where my derivative equals 0. But if I need to be specific, which I do, I need to be talking about the minimum. The minimum is created by what? Negative to positive change on the first derivative. So that means that x equals +1 is our relative minimum. So you can list it first. You could say x equals 1 is a relative minimum because f prime changes from negative to positive at x equals 1. I don't know that you necessarily have to say at x equals 1 again, but I just like to be clear there. Okay, so that's the answer and that's the justification. Let's look at part B. Explain why there must be a value c between -1 and +1 such that f double prime of c equals 0. This was what I mentioned yesterday. I'm sorry. Oh, yes. This is what I was mentioning yesterday about the mean value theorem and applying it with the second derivative and the first derivative, as opposed to yesterday we did it with, let's see here, let me get to that problem real quick. Yesterday we did it with problem number 1. Is there a number c on the interval such that g prime of c equals -4? We use the mean value theorem, okay? G prime of c equals g of b minus g of a over b minus a. We can do that with the second derivative here and the first derivative for the secant line, so to speak. So let's set that up in this problem. Okay, so that would be saying f double prime of c is equal to f prime of b minus f prime of a over b minus a. Our a and b here are -1 and +1. So we are saying that f double prime of c is equal to, so f prime of 1 is 0, f prime of -1 is 0, over 1 minus negative 1, so it really doesn't matter what the bottom equals, as long as it doesn't equal 0, which it doesn't, it equals 2. So that says f double prime of c equals 0. Now, it does say explain. You can't just show that work. You do need to give some explanation of what you actually did right there. So we need to establish that our function f prime, this time the function is f prime is differentiable. They told us that because they said that the function was twice differentiable. So therefore, it is continuous. Remember, it has to be differentiable and continuous to be able to apply the mean value theorem. And we showed the work. So we can say by the mean value theorem, there is at least one C between -1 and +1 such that f double prime of C equals 0. So pretty common question there. I've seen it here with the table problems. I've also seen it in other types of problems. So it may not just be in one of these types, but anytime you see that terminology, you should be thinking mean value theorem. Okay, you should be thinking mean value theorem. All right, part C. Part C says the function h defined by h of x is equal to the natural log of f of x. Find h prime of 3 and show the computations. So the derivative, I would write it in general terms first. So h of x is the natural log of f of x. So this is another chain rule. So the derivative of the outside, the derivative of the natural log is 1 over what was inside the natural log times the derivative of what was inside the natural log. So we have 1 over f of x times f prime of x. They want h prime of 3. So plug 3 in for x. So f of 3 from the table is 7. And f prime of 3 from the table is 1/2. So we have 1/7 times 1/2. So that's equal to 1/14. I haven't gone over the point breakdown yet. Part A was just a single point. A lot of times that'll be a 2-point, but on this one they just went with 1 point. So you have to have the answer and the justification correct on part A. On part B, they give 1 point for f prime of 1 minus f prime of -1 equaling 0. So you get 1 point for showing the work of the mean value theorem, and then 1 point for the explanation using the mean value theorem. You've got to use that terminology. Even if you show the work, you have to use the terminology. Part C is actually 3 points. They give you 2 points for the derivative of the composition function there, and 1 point for your final answer of 1 over 14. So we're at 6 points right now. Part D says to evaluate the integral from -2 to 3 of f prime of g of x times g prime of x dx. Now, I know that looks really, really funny, but this really is not that bad. Remember, when we're trying to figure out how to anti-differentiate something, the question that we should be asking ourselves is, well, what function do I take the derivative of to get what's inside my integral? So what did I take the derivative of to get that expression right there, the f prime of g of x times g prime of x? F of g of x. It's a chain rule. f of g of x. If we take the derivative of that, its derivative is f prime of g of x times g prime of x. Now, we do have to evaluate it from -2 to 3. So we plug in 3 minus, we plug in -2. So from the table, g of 3 is 1. G of -2 is -1. F of 1 is 2, and f of -1 is 8. So our final answer is -6. So they give you 2 points for recognizing the fundamental theorem of calculus here. And 1 point for your final answer. Excuse me. I've also seen, these are kind of common things that they'll do here in these table problems, but I've also seen part D as a multiple choice question. Just asking you to recognize that that's the reverse of the chain rule, and just being able to plug in your limits there. Okay? All right. Let's look at number 4. Similar scenario here with this table. We've got f prime, g, and g prime. This time they just say that it's differentiable. It doesn't say twice differentiable. It does say that g is strictly increasing. So a lot of times when they make mention of a detail like that, it's going to come into play a lot of times. Not always, but a lot of times. The table above gives values of functions and their first derivatives. The function h is given by f of g of x minus 6. Part A, explain why there must be a value r between 1 and 3 such that h of r is equal to -5. Now, we're talking about the original function here. So when we're talking original function, that's when you should think intermediate value theorem. You should think IVT. If it's talking about the original function, you should think IVT. Part B talks about the derivative, so that's going to be MVT, the mean value theorem. Okay, so original function, intermediate value theorem. Derivative, mean value theorem. So remember, with the intermediate value theorem, we need to show that on that interval, on one side of the interval, we're below the value in question. On one side of the interval, we are above the value in question. So let's find h of 1. That is f of g of 1 minus 6. So g of 1 is 2. F of 2 is 9. 9 minus 6 is 3. So h of 1 is 3. So that part's above -5. So we are hoping that h of 3 is below -5. We're going to have to do something else. G of 3 is 4. F of 4 is -1. -1 minus 6 is -7. All right, so what's the one condition for being able to apply the intermediate value theorem? Continuous, okay? Now, they didn't tell us that it was continuous, but f and g are differentiable. If they are differentiable, then they are continuous. If those functions are continuous, then its composition is continuous. So you can, I don't think you have to go through that whole explanation. I would just say h of x is continuous. Now, just as a little tip here, look at how this one's phrased. It says explain why there must be a value r. If it says that, then it's telling you there is. You just need to give them the reason for why there is. Sometimes they will say Must there be a value? Explain why or why not. That's where there could be the case where there's not because it's not continuous or something like that. But if it says explain why, you know it is. So you can just go ahead and say H is continuous because you know that has to be true. H is continuous and H of 3 is less than -5, which is less than H of 1. So by the intermediate value theorem, there exists a value R, could be more than one, but we know there's at least one, a value R between 1 and 3, such that H of R equals -5. So they give 1 point for the values of H of 1 and H of 3, and 1 point for your conclusion, making sure that you use the terminology intermediate value theorem. Don't abbreviate, okay, do not abbreviate. I think it's pretty widely accepted. I think all the readers would know what you mean by the IVT, but they do frown upon using abbreviation. So just write it out. You've got plenty of time. All right, part B, explain why there must be a value C between 1 and 3 such that H prime of C equals -5. Okay, so like I said, derivative, we're thinking mean value theorem, so we need to work out, well, we've already worked it out because remember, mean value theorem says H prime of C is equal to H of B minus H of A over B minus A. We just did H of B and H of A. We got that from part A, so just use that. -7 minus 3 over 3 minus 1. So that's -10 over 2, which is -5. So since H is continuous and differentiable, by the mean value theorem, bless you, there exists a C between 1 and 3 such that H prime of C equals -5. So 1 point, they give you 1 point for the H of B minus H of A over B minus A, and 1 point for your conclusion using the mean value theorem. So 4 points so far. We have 5 points left for the next 2 parts. Part C should be pretty easy here. Let W be the function given by the integral from 1 to g of x of f of t dt. Find the value of W prime of 3. So this is a fundamental theorem. We're taking the derivative of an integral. So we plug in W prime of x, we plug in our limit into the function that was in our integral, but it wasn't just plain x. If it's anything but just plain x, we have to multiply by its derivative. Okay, so you plug it in, multiply by its derivative. Just as a side note, remember if it was the bottom limit, we'd have to stick a negative in front of it. So W prime of 3, let's plug in 3, f of g of 3 times g prime of 3. Let's see here, g of 3 is 4. G prime of 3 is 2. F of 4 is -1, so we get -2. It says 1 point for the chain rule and 1 point for your final answer. So that makes me think that maybe if you forgot the g prime of x part, if you just had f of g of x, so your answer would just be -1. I think they may still give you 1 out of the 2 points. You just wouldn't get the full 2 points because you didn't apply the chain rule. I think that's how those would look. All right, now the last one. Here's the idea of the inverse. If g inverse, write an equation for the line tangent to the graph of the inverse at x equals 2. Okay, so here's how this works. We need a point and we need a slope. So we need a point, but we're talking about on the inverse here. So if we're at x equals 2, that means we need g inverse of 2. Our x value is 2, that means we need g inverse of 2. We don't have g inverse on our table. But remember what the inverse does, is it switches x's and y's. So if it's the x of the inverse, it means it's the y of the original. So the y of the original on g of x, where it's 2, is at x equals 1. So g inverse of 2 equals 1. That is our point. X is 2, y is 1 when we write our equation. Now, we need the slope. The slope comes from the derivative. We need the derivative of the inverse. We need the derivative of the inverse. So there's a rule for that. And that's supposed to be the little derivative symbol. There's a rule for that. It is 1 over, it's a composition, g prime of g inverse of the value. 1 over g prime of the inverse of the value. I think we've gone over this. I think I remember sharing this rule with you. It's just been a little while. Okay. G inverse of 2, we just figured that out. It's 1. G prime of 1 from our table is 5. So 1 over 5 is the slope of the inverse at 2. So the equation of our line, y minus y is equal to slope times x minus x. So you get 1 point for g inverse of 2 equals 1. You get 1 point for your slope and 1 point for the overall tangent line equation. So it's worth a shot here. If you're not incredibly sure where to get the exact values, give it your best guess, label them, and at least write down an equation of a tangent line that makes sense. Okay? You know you need a point, you know you need a slope. If you don't remember how to deal with the inverse, just make some up, label them, and at least write an equation of a tangent line. It may give you some points for that. Okay? All right, we are going to do one more. Let me glance at number 5, see if there's anything new or if I just want y'all to do it. I want y'all to try it.